Good morning, everyone. Hope all is well. Hope everyone's doing all right. Everybody's having a great day and had a great weekend. All right, so let's see. Anybody have any questions or anything before we get rolling? Straight.
I do.
Uh-huh.
So, when do you think we're going to actually do the test for this chapter?
Oh, well, we're going to do 1.7 today, and after that, lectures for chapter 1 is over, and
Okay.
you have access to knock out the test. It's already posted. At least it's supposed to be. And if you don't see it, let me know. But we were going to talk about that before we closed out today.
Okay.
All right. So let's go ahead and do that. Look at 1.7, and we'll talk about how we're going to handle chapter 7. I mean, chapter 7, chapter 1. All right, so 1.7 is linear inequalities and absolute value inequalities. All right, so up to this point, we dealt with equations. So looking at the difference, and of course, if I scroll it too fast, let me know. But talk about the difference between an equation and inequality. First thing is that one has an equal sign, the other one has an inequality symbol. So your equation has an equal sign, inequality has an inequality symbol. When we solve our equations, and let's look at a linear equation, we're only going to get one solution. So in this case, 2 plus 5 is equal to 7. So our solution would be 2. We get one solution, and our only solution is that 2. You want to know when is x plus 5 equal to 7? That's when x is equal to 2. Now, when you're looking at a linear inequality, you want to know when is x plus 5 greater than 7? In other words, when is the left side of your inequality greater than 7? And your answer will be when x is greater than 2. So that will be an infinite amount of solutions, infinitely many solutions. So anything greater than 2 will make that a true statement. So if it's 2.1, 3, 5, if 5 plus 5 is 10, 10 is greater than 7, 100 plus 5, 105 is greater than 7. So anything greater than 2 will make this a true statement. So that's why you have an infinite amount of solutions, and that's considered a solution set. So all values greater than 2 will be a solution. Any questions before we go any further? All right. Let me scroll up. So looking at our inequality symbols. So we have the less than, and then we have less than or equal to. That's the less than symbol with the bar under it. Then we have greater than, and then the greater than or equal to will be the greater than symbol with the bar under it. All right. Also, when we go to solve these, you'll have 3 parts or 3 different ways you can represent your actual answer. You can have your solution set. We can graph or we can write it in interval notation. And we were talking about graphing, we were just talking about graphing generically on the number line, not your XY plane. So we're just talking about shading to the right or left of your value. So your less than and greater than symbol, we'll always use parentheses. Less than or equal to, greater than or equal to, we'll always use brackets. Negative infinity, infinity, will always use parentheses. So what does it mean to use parentheses versus brackets? Parentheses mean you will exclude that value. In other words, not use that value. Bracket mean you will include that value, which means you will use it. So you'll see what I mean in a second. And notice parentheses will always be on your infinity signs because you never can include infinity. You know, you can always go to that next value. Okay. Then if you have previous relationships with or previous experience with the open and closed circles, that's what I wrote here in the green. The open circle means the same thing as parentheses. Closed circle means the same thing as bracket. But if you don't remember open closed circles or never use them, don't worry about it. I was just trying to connect previous, experiences with something that we use now. But open circle means the same thing as parentheses. Closed circle means the same thing as brackets. All right. So what do I mean by include and exclude the value? So if my solution set is X is greater than 2, that means all values that are greater than 2 will be my solution, but 2 is not included. I want the values that are greater than 2. 2 is not a part of my solution set. So that's what we mean by exclude 2. You would not use 2 as a part of your solution set. Now, if you do X is greater than or equal to 2, that means 2 is a part of your solution set because it says or equal to. So 2 would be a part of your solution set in order to make that statement true. So that's what we mean by include versus exclude. That or equal to symbol will let you know if you're going to include that number or not include that number. All right, scroll up. Is that okay? All right, so in the black is just some specific examples of how we would use our 3 pieces to represent the same answer or the solution set. So if I were to solve and I have X is greater than 2 as my solution set. Now, when you look at your generic number line, let's say if I look at -2, everything to the right of -2 will be greater than it. Everything to the left of it will be less than it. Or if I were to look at +1, everything to the right of 1 will be greater than it. Everything to the left of 1 will be less than it. So that will always be the case. So if you're talking about greater than, you will always shade to the right of your number. If you're talking about less than, you always shade to the left. That will always be the case. That will never change. So if you have your number, greater than will always be to the right of it. Less than will always be to the left of it. So going back here, if I have X is greater than 2, I'm going to shade to the right of 2. Now, because it's the greater than symbol, I'm going to use parentheses over the 2. And like I said, shade to the right. Then also notice for interval notation, we're going to read exactly what we see as far as our shading is concerned. We go from 2 to infinity. So that's why it says it has 2 comma infinity, parentheses over both, because we have the greater than symbol, and then infinity signs will always use parentheses. Now, difference between that and this next row or column, we have the or equal to symbol. The only thing that changes is that we're going to use bracket over the 2. Still shading to the right because it's greater than, and it's still 2 to infinity. but it's just a bracket over the 2. Once again, your infinity sign will have um, your parentheses. Any questions? Any questions? Mm-hmm.
So whenever you're doing this and making the brackets and parentheses, you make it half, well, not half and half. You make each side similar to fit what it actually is. Like you the bracket on one side of 2 to show that you included 2,
Mm-hmm.
and a parentheses on the side of infinity.
Mm-hmm. Yep.
Okay.
Infinity will always have parentheses beside it, no matter what's going on with your numbers. Yep.
All right.
Mm-hmm. All right. So the next thing is I'm just going to do a generic graph of all of the scenarios that you will see. Here specifically we use 2, but if you look at this red statement right here, it says A and B, which is going to represent real numbers. So these are going to be the scenarios you will have no matter what your numbers are. Just your symbols will dictate whether you shade to the right or left. So the first 4 in the chart, we already explored the first 2 when we did x greater than 2. But let's say if x is greater than a represents our number, parentheses, shade to the right for a, and then a comma infinity parentheses over both. So for that second row is the same relationship, except because it says or equal to, that means we have a bracket on the a. So it's the same thing that we just did with the 2 in the previous example. Now for the next 2, it says x is less than a. So this means we're going to shade to the left. Because it's less than, we use parentheses over a. Then also notice your interval notation. You read your graph from left to right. Everything needs to reflect each other. So it's coming from negative infinity to a. So that's why this is written negative infinity comma a instead of a infinity. So it's negative infinity a, parentheses over both. And then for that 4th row, same shading, same relationship, just that you have or equal to. So you have bracket over the a.
You said why did the infinity sign come first?
Because right here, infinity, negative infinity is first. If you read it from left to right.
Okay.
And so it wants you to hold true to every piece needs to reflect each other.
I might be jumping the gun with this question, but how are we supposed to fill these graphs in on my math lab?
They will give you A, B, C, or D choice.
Okay.
And so, in other words, let's say if it was 2, then they have 2 here shaded to the left, and then the other one might be 2 parentheses shaded to the right, and then the other one might have a bracket instead of parentheses. It just give you 4 choices to choose from. All right, everybody done with those 4? Can I scroll up? I guess because the other one. Scroll up. All right, so the next 4, these are coming into play when we have a 3-part inequality. I'll show you one of those before we close out. But this says that x, our solution, is greater than a, but less than b. So that means we're talking about in between a and b. And so you shade in between a and b, parentheses over both, and interval notation goes from a to b as far as our solution set is concerned. So the next one, the only thing that changes is that we're going to have a bracket over a because we have the or equal to sign attached to a. Oh, what just happened? Hold on, guys. There we go. All right. So, and then the next one, same relationship once again, but the bracket is over B this time. And then the last one has bracket over both. So that's what we have going on here. All right. So you're gonna let me know if I'm going up too high. Somebody says in the chat. Mhm. So now solving linear equations, linear inequalities, they're going to be the same process as solving your equations. It's just that when solving linear equalities, you have to consider one thing, and that's this piece right here. It says if you multiply or divide by a negative number, then you must change or flip the inequality symbol. So it depends on your terminology. Will change or flip your inequality symbol. Anybody still holding on to the chart? All right. So a simple example of that scenario, we have negative 3x is greater than 17. In order to solve for x, you have to divide both sides by negative 3. All right. So if it was negative 3x greater than 17, then when you divide both sides by that negative 3, you have to change your inequality to less than. And so now your solution set is x is less than negative 17 over 3. Right. In the green gives you both of your other possible ways of representing this answer. Now, Math Lab, they may ask you for, one of them. Maybe they just ask for the solution set, or they may ask you for two of them. Don't know if they ever ask for all three at the same time, but they could ask you for either one of the three. You know what I mean? So just make sure you're efficient at all three of them, no matter which one they ask for. So with that negative 17 over 3, we're talking about our solution set are the values that are less than negative 17 over 3. So you're talking about shading to the left of, and we use parentheses over the 17 over 3. And then once again, your interval notation will reflect that same type of relationship. We read the graph from left to right. So that's negative infinity to negative 17 over 3, parentheses over both.
This is one of the easiest lessons so far.
Well, I'm glad you're all right. I'm glad everything's all right.
Yeah, I was wondering why you didn't start off the the whole year with this.
Hey man, I only call it like I see it, man. I just it's 1.7. What can I do?
Well, just flip the numbers around. You do every other time.
Are we done with that? Can we scroll up? All right. So to solve, just like I said, you will solve it the same way we would our regular linear equations. Just that if there's a negative that we would need to multiply, divide by, then we need to make sure we're cognizant of that because we're going to change our inequality symbol. So looking at this one right here, we have 3 minus 2x less than or equal to 11. So we will subtract 3 from both sides, which will give us negative 2x is less than or equal to 8. So since we have that negative 2 sitting in front of x, we divide both sides by negative 2. But once again, we're dividing by a negative. So we need to change that less than to greater than. And since it's greater than, now that means, well, we have our solution. X is greater than or equal to negative 4. And then we're going to shade to the right, bracket over the negative 4. And then negative 4 to infinity will be our interval notation. Then you learn in the first half semester is going to be in the final. Well, it is supposed to be cumulative, but the way this class works, everything builds upon the next thing. So even if I don't use a problem from chapter 1, what you learn in chapter 1 will be imperative for you to do chapter 4. So that's how that's why, you know, I have to put in due dates to kind of try to force you to do stuff at a certain time. So it's building upon the next thing. So it's like, you know, you can't get to step 3 unless you've done step 1 first. You know, you stepped on step 1 first. So even if I do the test just on chapter 4's content, your knowledge of chapter 1, chapter 2, and chapter 3 will be reflected in chapter 4. So, it'll build upon itself. So, you know, that's the type of thing that it does. Somebody asked in the chat, I don't know if you guys can see it. Someone asked in the chat, is the first half content going to be on the final exam? So this type of class that really, what you learn in the first half of class will be reflected on that final exam. Because sometimes I just do the test on just chapter 4's problems, but like I said, solving and all that is in chapter 4. So, all right, scrolling up. All right, so here we have x plus 3 over 4 is greater than x minus 2 over 3 plus 1 over 4. Here, what I would do is find the LCD so I can get rid of my fractions. We talked about clearing out the fractions before. So 4 times 3 is 12. 12 is that smallest number that both 4 and 3 can divide into evenly. All right, can I scroll up on the other problem? All right, so I will multiply both sides, or in other words, each numerator by 12. So we have 12 times x plus 3 over 4, 12 times x minus 2 over 3, 12 times 1 over 4. Now, what that allows for us to do is divide the 12 into, well, not divide the 12, divide the 4 into the 12. And that'll leave us with 3. Divide the 3 into the 12, leave us with 4. And then divide the 4 into 12, once again, leave us with 3. And then we have this result. 3 times x plus 3, 4 times x minus 2, 3 times 1. And we could distribute. So that'll be 3x plus 9 greater than 4 times x, or 4x minus 8 plus 3. Combine your like terms, -5 plus 3, I mean -8 plus 3 give you -5. So now at this moment, I have 3x plus 9 greater than 4x minus 5. My goal now should be get all of my terms with x on one side, all of my terms without x to the other. That's what I did here. I subtracted 3x, added 5. And the result is 14 greater than x. All right. So, go ahead.
Did you do the 3x first and then do the 5, or did you do it together?
I just ended up doing them together. You know, I know y'all pros at it by now, so I just threw them together. But you can do it separately. You just subtract 3x and then add 5. Yeah.
Why do you have the x is less than 14? Is that just to show the other side of the solution set?
Well, that's what I was about to get to next.
Okay.
So basically, Math Lab a lot of times want the x to be on the left side. So if you ever solve, so I purposely did this way. So just in case you were to solve with your x on the right, just make sure you properly transpose the x to the left if you need, if you have to. So just hold true to the relationship. If the mouth is open towards 14, when x is on the right side, then the mouth should be open towards 14 when the x is on the left side. So you can look at it like that. But it is possible that they may want x on the left. And like I said, so if you end up solving and have your x on the right, just make sure you properly reflect that the way that they want it. So just be careful with that. Because that's what it, if you were to read it from left to right, x is less than 14 is your solution set. And so you're talking about x is less than 14, we're going to shade to the left and use parentheses. And then that interval rotation is negative infinity to 14. And so also what should be seen as a benefit to being able to transpose it properly is because we normally read it with the x being on the left anyway. So, and that's what we've been talking about, even creating our 3 relationships. We talked about x being on the left. So. All right, let me scroll up. All right, so last thing with inequality, well, with linear inequalities anyway, 3-part inequality. So it's called a 3-part inequality because there are 3 parts. 1, 2, 3. And we want to solve and leave our variable in the middle. So remember, if you remember those last 4 rows in your chart, x was in the middle and you had a and b on the outsides. So we want to solve with x in the middle. And if you had this equation and didn't have that left piece, you want to solve for x, what you would do is subtract 1 from both sides. Well, you hold true to that same thought process, but you're going to subtract 1 from all 3 parts. So that's what we did here. Subtracting 1 from all 3 parts. So that's -4, 2x, and 1. And still trying to solve for x. Divide by 2. And x is greater than -2, but less than or equal to 1. So we'll do a bracket over 1, parentheses over that -2, shade in the middle. And then interval notation holds to the same relationship, -2, 1, bracket over 1, -2, has parentheses. Any questions?
I'm gonna say what others say. This is real understandable.
Say that one more time now.
This is real understandable.
Oh, okay, cool, cool, man. Well, you know what I think is going on is that you guys have sat in this, what, 3 weeks now? And now stuff is just saturating your brain in such a way that, you know, this stuff is just easy to you, man. You know, it's easy to y'all. So that's good to go. Now y'all can do calculus, right? See somebody here. Somebody said no. So we have one more thing to talk about, absolute value inequalities. And see what multiply by negative do we have. When you say flip the whole thing, it says if we multiply divide by a negative number, do we have to flip the whole thing too? Not sure what you mean by whole thing too. Are you talking about this whole thing?
I think they mean if there's more than one inequality symbol.
Yeah,
Like,
I mean by that.
if
Yep.
if that was a -2,
Mhm.
would we switch both symbols?
Yep, because you would divide each one of them by negative. So you would have having this, well, when you divide, that would be a positive. And then that would end up being like that. So, well, yeah, it would have been like that. So yeah, it would have been flipped. And then if you want to write it properly, you would write it like this. Not sure if you guys are going to come across anything like that, but yeah. You know, because the larger number is always written on the right. So when you divide it by negative, everything, you know, all the signs would change. Yeah. So yeah. Well, yeah, if you see one like that, feel free to, you know, if you want to see us walk through it, then we can. But I don't know if you guys will see one like that.
My math lab comes out the woodworks with some crazy questions. So
But yeah, if you got them, you know, I'm here. Next class will be all for you guys to ask whatever questions you want. That whole class is dedicated to you guys asking whatever you want. But we'll talk more about that, you know, when we close out. But yeah, yep. So most definitely next class will be for you guys to do that. Anything you see that you may look funky to you. All right. So the last thing out of this whole chapter is absolute value inequalities. And here's just key to watch the setup. Once you have your setup, then it's the same thing that we just finished doing. So let U represent an algebraic expression, and C is going to be a positive number. We're going to talk about what that means in a second, in a few, you know, if it's a negative number. Right now, we're just looking at positive numbers. So if you have the absolute value of U is less than C, all right. Absolute value of U is less than C, then we're going to rewrite and solve in this format. U is less than C, but it's greater than negative C. But then if you have the greater than C initially, absolute value U is greater than C, then we're going to write it the way we see in this green box right here, in which we have U is less than negative C or U is greater than positive C. And the reason these things occur is because of our absolute value sign, in which, remember, with absolute value, if you plug a value in for the absolute value, the result is going to be positive no matter what it is. So that's why these things hold true. And then also in this red box, if it has or equal to, it's the same thing. You know, make those same setups. If it's less than or equal to, do the same thing as purple box. If it's greater than or equal to, you do the same thing as the green box. All right, you ready to try it out? So if we have the absolute value of x minus 4 is less than 3, the key here, well, we already see that we have absolute value, but the key here after that is the fact that we have a less than symbol. If it's less than, then we're setting it up like the purple box. So notice what I did here. Our U is x minus 4. C is that 3. So that's why we have less than 3 on the right, but less than negative 3 on the left. So that's the setup if you have a less than symbol. All right, any problems with that? Then from there, you solve the 3-part inequality by adding 4 to all 3 parts. That'll give you 1, x in the middle, 7 on the right. Shade in the middle of 1 and 7, parentheses over both. Any questions? All right, can we scroll up? All right, so for the next one, once again, we have a situation in which x is on the right side of our inequality. So what I did was flip that. Just like I said, you should get used to doing that and being okay with it. Once again, if the mouth is open towards, let's say x this time, then make sure it's open towards x, when you flip it to the other side, just keep the same relationship that it has initially. So you can read it from left to right, the same way the same way that we have everything set up. So this time we have the greater than symbol. So notice how we set it up into 2 separate pieces instead of, being together like this one is. We set it up in 2 separate pieces. We got 5 minus 2x is less than -7. 5 minus 2x is greater than 7. So the greater than symbol sets it up this way. All right, questions before we go up? So solve it the same way you normally would, subtracting 5 from both sides in both cases. And just circle that just to make sure we notated that we're going to divide by negative. So just like your classmate mentioned in the last problem, we're going to have to flip that inequality in both cases. So x is greater than 6, and then x is less than -1. Make sure we are okay. All right. So we're talking about x is greater than 6 and x is less than -1. And somebody asked in the chat, why did we do it this way versus doing a 3-part? And just to show you real quick, and then we'll come back. It's all about the setup. This one has greater than symbol. This one has less than symbol. So going back here, if it's less than, we can do the 3-part. If it's greater than, we have to do it, the 2 pieces this way. Yep,
Can you keep
the
going?
sign.
I didn't write it down.
Okay, the sign, yes, somebody said the sign requires a different method. And it's really basically what's happening here is that you're writing it the way you see it, and then you're writing the opposite, and you're using the opposite sign and the opposite inequality, and that's what's going on here. So the way that the absolute value is set up, that's why it prompts you to do that. Yes, so if it's less than, you put it in the 3-part inequality, but if it's greater than, then you set it up, like I said, in this way right here. All right, cool. Now somebody said they were still copying this. They didn't write this down. Let me know when you finish so we can scroll back up.
All right, I'm done.
All right. So let's go back. Use that. And so this is where we were, finishing off that problem. And so, yeah, if a negative happened, you swap signs. Yep. Oh yeah, I didn't finish just talking about the answer. So greater than 6, we're shading to the right of 6. Less than 1, we're shading to the left of -1. And then or is represented. Oh, still have my eraser. Yep. So or is represented by the union sign. So we use our union sign in between our two parentheses when it comes to interval rotation.
When you change the less than and the greater than sign, did you just add like a negative to the number?
Now, when you said, well, are you talking about going from here to here?
No, on the two different sides.
Mm-hmm.
How you change the symbol,
Uh-huh.
and one of them got a negative and one of them got a positive.
Well, this because -12 over -2 gave you a +6.
No,
And
I'm
then
talking about the question, the equation. When they say 5 minus 2x is less than -7,
mhm,
and then 5 minus 2x is greater than 7.
mhm.
So one of them got a -7 and one of them got a +7.
Yeah, that comes from going back to this right here.
Okay.
Yep. So you're leaning on that, and because you do the same thing right here. You're going to use that sign, what you see, the positive number, and then the negative number as well. Mhm. All right. Anything else before we do at least one more? Mhm. Can we scroll up? Am I still copying? All right, so I think this is the last one. Yep, it's the last one. So we have -2 absolute value of 3x plus 5 plus 7 greater than or equal to -13. So first thing you want to do is isolate the absolute value. You can't make your comparison or do the flipping and applying of the signs like we did with the other two until your absolute value sign is isolated first. So we can go ahead and subtract 7 from both sides, then divide by -2 once again. Dividing by a negative, we need to change that inequality. So it goes from greater than or equal to less than or equal to. So we have absolute value of 3x plus 5 less than or equal to 10. All right, everybody okay up to this point? Yep. All right, so don't copy this part yet. We'll come back to this. I don't know why I broke it up like that, but we'll come back to that. Let's go back to the purple box right here. All right. So now we'll go ahead and set it up. We have 3x plus 5. So remember it was less than. So we have less than 10x. Hold on. Oh, Mr. Was that Bracy that put that in there? Less than. You had it, you still had it with greater than, Mr. Bracy. But remember we switched it to less than because we divided by -2. So since it's less than, then we have to do set it up this way.
Yep, my bad.
Yeah, no problem. I just didn't want to, say yes or gloss past it, and then we didn't talk about it since you put it in there. So yeah, so now we set it up this way because it was less than. So 3x plus 5 is less than or equal to 10, greater than or equal to -10, and then solve the three-part inequality. Is somebody trying to come in here? Yep. All right. Solve the three-part inequality by subtracting 5 for all three parts. Subtracting 5 from all three parts gives us -15, 3x, and 5. And then from there, divide 3. And that's -5x and 5/3. And there were your three pieces. So x is greater than or equal to -5, less than or equal to 5/3. So you shade in the middle, use brackets over each, and then your interval notation reflects that same thing. All right, so when you guys finish copying that, we'll go back up, get that middle piece that I talked about, and then that'll be it. All right, we good? Can I scroll up? All right, so if you remember, I mentioned before that C was positive. That number on the right of your inequality is positive, but if it's negative, there are two different scenarios that could occur. And of course, somebody would ring the doorbell. I hope that ain't the guy that's supposed to be checking on my leak. Hold on, let's go ahead and finish this now. I'll go check that out real quick. So yeah, absolute value of x plus 7, if it's greater than a negative number, right, absolute value cannot be negative. So you ask yourself, when is the absolute value of this greater than -5? The answer is always. So if it's compared to a negative number, that's going to be all real numbers. But then if the absolute value of x plus 7 is less than -5, that's never. So that means your answer would actually be no solution. So that's why when we talked about it initially, it said if that C is positive, then you have those results. But if you compare it to a negative, those are your two options. Let me see who's at this door real quick, and I'll be right back. Sorry about that. All right, guys, sorry about that. The guy came a little early. I had a leak in my garage. Not a flood, but it was enough that it messed up some stuff. And so he was supposed to come at 12. Normally, if they should give you an hour from 12 to 4, they don't come until like 4. Who knows? Stuff happens when you really got to do stuff like that. So any questions on anything I put on the notes before we talk about how we're going to handle things moving forward? Everybody good? Everybody straight? Okay, cool. So that is it for chapter 1. So let's talk about due dates. I decided, talk with my last class because I have another 161 as well. I'm going to give you a little bit of a grace here, a little more of a due date than normal because, we got the 19th, the 26th, and then we got 10/3. So I'm going to make the due date for this October 3rd. if you don't have to push it all the way to October 3rd, I would suggest that you not do that. You know what I mean? Because that's a long ways away. We will continue to be going into chapter 2. So you don't want to just be sitting in chapter 1 and letting chapter 2 pile on top of you. But I know some people have had trouble, with whether it be My Math Lab or logging on to My Math Lab or whatever. So, just try to give you enough time to say, okay, I have enough time to get chapter 1 stuff done before a due date has been implemented or before I have to ask for any type of extension. So that's why 10-3 is there. That's a Sunday. Normally I probably would have said the 26th, saying, give you 2 weeks to knock it out or whatever. But yeah. So 10-3 will be the date. I haven't changed it yet. I just decided on that date this morning because we just finished out chapter 1 this morning. So all of chapter 1 will be set for that due date. So you're talking about all of the homework, the test review, and the actual test itself. Test review is not mandatory, but especially going into next class, remember I said that's going to be an open class for you to ask whatever questions you want. I would suggest you at least take a look at the test review to see if there are any problems that even if you haven't attempted, you want to see me do them. You know what I mean? I'm not gonna be like, did you try it? Yeah, I'm not gonna do that. It's just, you asking. The next class will be you asking whatever questions you want to ask, and I'll knock them out. Not gonna do anything new. Not gonna get into chapter 2. Let's say if only one person have one question, and then for a few minutes we sitting there looking at each other and everybody just good, then that'll be it for today. I'm not gonna throw any new material at you next class. It's just gonna be a question time for you guys to take advantage of. Now, next Monday, that's when we'll start chapter 2. Don't forget this test you can do on your own. You're not waiting for me. You get 2 shots to get the best grade possible. And your scratch work for your test, not homework, but just your test. You shoot that to me, whether it be taking a picture with your phone, scanning it, or whatever way works best for you. Let's see, we got somebody in the chat. Just have a problem understanding it and then going to the board. I'm trying to reach out with you. Oh, well, like I said, though, if you try some problems between today and next class and you see something and you're like, okay, I don't understand this, next class will be the moment to bring them up and we can just run through whatever it is. You can ask whatever you want to ask about them. And also don't forget, you can email me and set up a Zoom session with me as well. That's individual. I have met with some of your classmates already. So it's up to you to set that up with me if you want to meet with me. I don't have a problem with doing that at all.
Is it a timed test, or is it a printout test, or?
No. You would just do it through MathLab, and it's not timed. The only time you would actually have a test that's timed is if we have a proctored test and we have to do it, within the class, class time, So that's the only time you would have.
Are we having proctored tests? I can't remember if you said.
I know for a fact we're gonna do the final exam as proctored because that's required. Haven't decided on which other tests will be proctored. If it just depends on how things flow. I'll say it like that. But we know for a fact we have these bookends. First test is not proctored, final exam is proctored, and then the other ones are flexible. So we'll work it out from there. But whatever we do, you will have a heads up, more than enough time to, prep for it. You serious at 1.5 haven't been able to complete the homework. Okay, not a problem.
We're allowed to use our notes for the test, right?
Yes, I will not take those from you. But plus, don't forget, there's no way for me to govern that at all. You know what I mean? I can stress about it if I want to, but it really won't be a way for me to govern that. So yeah. So rest free. There's no honor code on that part. Just make sure that it is my preference that you are doing it on your own, because remember the final exam, you are expected to be doing it on your own. So you want to make sure you have your understanding going into that most definitely final exam. So yeah, if the recording feature was turned off, wouldn't it? Why would it be horrible if the recording feature was turned off? What's going on that I don't know about? So yeah, let's see. Let me see, buddy group.
You said we have 2 attempts on the test?
Yes. And be honest with you, if you come to me and say, can I get a 3rd attempt? I'll probably give it to you. It's not, so, but that's just you, and if you want to take time out to do it the 3rd time, I don't have a problem doing that. But without asking, you get 2 shots. Yep. All right. And oh, also, if there's anything that happens, and I wish I said this in my last class, anything that happens, you get kicked out of math lab or something like that, and some type of issues occur, you got to let me know so I can adjust it or address it in any way, shape, or form. If you type in an answer, in other words, let's say they wanted 2 for the answer and you do x equal to 2. They will mark it wrong if they didn't want x equal to 2, but I won't know unless you tell me. So review your tests and make sure your answers are put in correctly. And you have any problems or questions with anything like partial credit or anything like that, you got to shoot me an email. I'm not combing through all tests to see if I can find extra points to add to tests. But so I wouldn't know to adjust test scores unless you tell me, hey, Mr. Sucker, I got, problem 6, 7, 8, they got marked wrong and I feel like they should have been right. And looking at the test, it was supposed to be marked right. Something like that. Let me know and then I can go in and make the adjustment. But once again, I wouldn't know unless you tell me. Mr. Bracy, your hand up?
Yes. Last class, I asked you a question about whether or not you're capable of hitting that share button on that OneNote and giving some of us access to see the direct notes themselves. I'm a very
oh yeah, I forgot to look into that.
I mean, it's probably good. Like, just make a
shoot me
copy of it.
Yeah, shoot me an email and remind me about that because that's
right.
something I would have to do off, after classes are over when I'm doing my, my other extra stuff towards my classes. So that would be one of those things. So yeah, shoot me an email to remind me to do that, and we'll go from there. That'll help me out. Yes.
On the test, is it multiple choice or is it like how the homework is? You fill in the blank.
It's like the homework.
Okay.
Yep. Anything else? Anybody else?
Yeah, am I the only one that thinks you remind us of hanging with Mr. Cooper?
What? Look, I think you might have tapped into the time machine. I don't even know if anybody know about that.
I'm showing my age. I'm definitely showing my age.
Yeah,
Right.
what is that?
And I was just about to say, what is that?
Yeah. You
What
stepped in
is
the time
that?
machine.
It's a
Y'all
show.
go. It was
It's a
TV
show. I know what
show.
you're talking about,
Yeah.
Brendan.
Yeah, y'all go Google it. Just 5 minutes. Tell me that this guy does not remind you of hanging with
Get
Mr.
out of
Cooper.
here.
It's a good thing. It's not a bad thing. It's a
Right.
good thing.
Oh man, that's too funny. And the fact that he played basketball, well, I was actually the director of a whole program at one point too, basketball and stuff. So that's kind of funny. Yeah, you took us way back on that one. But let's see. Anything else before we close? Oh yeah, if you're having issues that class time, well, I just want to reemphasize this. If class time is not enough for you, and you have some stuff that we need to iron out, make sure you shoot an email so we can set up a time to meet. Yeah, that's the only thing I can say to that, right? Because class time sometimes isn't enough for that one-on-one, like real type of conversation, and sometimes it's not even that much, but you don't know it's not that much until we sit down and actually talk. So, make sure you shoot me that email so we can make sure you're straight going into the test. All right. Anything else before we close? Like I said, I got to take care of this man with the flood in my garage. And he's being patient, to be honest. So I appreciate him coming through. Anything else? Anybody else? Everybody good?
Nope, all good.
Okay, cool. Like I said, bring those questions next class so we can have a full class of questions. Outside of that, I see you guys next class. Have a good one. Be safe.
Everything.
All right, y'all have a good one.
Thanks.
Good
Take
day.
care.
Thank you.
Thank you.